Hi, I'm Vishal Gangarapu, and welcome to my talk on machine learning for smarter expense management. I have over 13 years of experience in finance digital transformation, focused on enterprise performance management tools and expense optimization. And today, I want to share some lessons I've learned along the way in my career journey, and I hope this would be useful for most of you listening here. In today's Asian world, we see many organizations focused on optimizing and reducing expense base as a way to improve their profit margins and give a better return to their shareholders. However, we see many financial teams, such as FP&A teams, struggling with inaccurate and inefficient processing of expense data. They spend excessive time with manual reconciliations and categorization, while strategic decisions are hindered by incomplete and inaccurate expense forecasting. Some of these challenges can be addressed by utilizing machine learning models to transform how businesses manage, analyze, and optimize their expenses. I've used financial services as a reference for many of my slides here, but these concepts apply to pretty much every industry out there. So without further ado, let's just jump right. So to set a baseline, let's talk about some problems with traditional expense forecasting methods where there is no utilization of historical data, trends, and patterns to refine your expense forecasting. So with those traditional methods, we see about 27% of forecasting accuracy, which means your expense forecasts deviate that much from your actuals, undermining your budget process. And we see about 42% classification errors. So these are pure expense categorization classification, and it could lead to significant misallocations of expenses across departments and skew their performance. And overall, this leads to high budget volatility, meaning the way when you start off your budget exercise and as you, there's a huge variation in the trust in the budget exercise. So as you can see, traditional methods fall short of expectations and we need a smarter approach. So what is that smarter approach? Let's just get there. Now, this approach is basically categorized into 4 different steps, and it's a sequential iterative process here, starting with organizing your raw financial data, which includes your expense data, into structured taxonomies and strategic hierarchies, which make it an optimal setup for machine learning analysis. And once you have your data ready to go, you can deploy any basic out-of-the-box machine learning model, or you can build your own custom to analyze that data and identify some hidden patterns, correlations, and anomalies with any complex expense. And after your initial analysis, you can generate some insights and discoveries using some strategic business intelligence tools like dashboards, or even simple analysis tools like Excel, to give you some insights that help you make some strategic decisions, which drive measurable cost reductions and financial optimization. And once you make your decisions, that you can input back into the model to make it. So let's just go a little deeper here. And before we go into the technical side of things, I want to stress upon a few definitions and the way we define expense and department hierarchies in an organization to make sure your expense forecasting with machine learning works the best. So my first slide here is about cost and profit centers. And this concept, I know, is not very new. Every organization, every company out there has a concept of cost and profit centers. But I've seen a simple nuance missing in many organizations, which I want to highlight here. So I'll start off with the basic definition of cost centers, which you as you think of, these are the departments, or in terms of data, the fields where you book your expenses. And these are expenses that could be generated while you produce a revenue, or it could be overhead costs necessary for running the business, which includes the pure cost centers such as HR, IT, and facilities, costs, and any non-personal expenses such as data fees or subscription fees. So in short, cost centers are where you book your expenses. And moving on to the next definition here, which is profit centers. These, as the name suggests, strategic business units where those front-end trading desks or sales divisions or product line divisions where you produce or make a sale and generate revenue. And that revenue is booked against these profit center codes. Now, the nuance I want to highlight is every profit center should and must have a equivalent cost center where you book your expenses against. So that means every profit center has a cost center, but then not every cost center has a profit center. So those pure cost centers like IT and human resources, they don't generate revenue, so there's no need for a profit center code for those costs. Assuming that is clear, let's get to the next set of business definitions. So I want to talk about the expense hierarchical framework here, which divides expenses into 3 different categories, starting with direct expenses, which make about 38% of any organization's expenses. These are costs that are tied specific to revenue generated activities with clear ownership of where the revenues are coming from. So these could be personal compensation and benefit expenses related to people and teams in profit centers, or it could be direct revenues produced in revenue units such as license costs or data subscription fees and things like that. So in short, direct expenses are booked to costs in which it gets allocated to. Now the next bucket is allocated expenses. This sounds a little bit like direct expenses, but here I'm more focused on the organization overhead costs, which you can think of the technology costs, the IT costs, the compliance, legal, risk, teams costs, where these are all essential for a successful running of it. And these are pure cost centers, like we spoke about in the earlier slide. And these could have some expenses which could be confused as direct expenses because all these functions have dedicated personnel. So all those expenses are direct expenses in those cost centers. But then at the end, all these expenses get allocated to front-end profit centers, which would then help you figure out your allocated expenses are generated in pure cost centers, but then they get allocated to profit centers. So the waterfall method is simply a unidirectional flow of expenses, where when one department allocates costs to another department, it only works one way. And so these overhead expenses make about 45% of any organization's expenses, so roughly half, and that's very standard. And then the third bucket here is the variable expenses. So these, as the name suggests, are variable, and they scale up as your organization or your company scales up. And these are produced as and when you're producing revenues, or it could be any non-overhead costs that are directly a function of your revenues. So these expenses are a bit of an exception because these are produced during revenue generation process. So these get booked directly to profit centers. So this is a slight deviation from what we discussed earlier. And I would like you to, so now this is established, let's go on to the more technical aspects of using machine learning models. So the first step for building any technological solution to make your business better is to have a strong data foundation. And the first step there is to identify your required data types. So in this case, we are talking about expense forecasting. So we need to have clearly defined transaction records with complete metadata. We need historical expense categorizations between IT costs, real estate costs, and so on. Different categories of expenses have to be clearly defined. And we also need vendor information. So these are third-party vendors and companies that we make payments to. And once you identify those data types, you need to prepare your data to be able to be effectively used in a machine learning model. So that means you need to standardize your transaction formats, handle missing values in your data. This is, in other words, mastering your categorization data. And we also need to normalize your vendor information in terms of formatting and syntax so that the machine can recognize it's vendor information every time you input it. And then once you have these steps done, you need to build your data structures around your transaction records with unique identifiers such as the primary keys and foreign keys. And you have to have your data that is required for your organization. So if it's a financial services firm, you might need some external data as a reference data. So that's an example there. So any robust machine learning implementation requires comprehensive data spanning at least 12 to 18 months before you can utilize that to do your budget versus actual reporting and forecasting. And as they all say, how properly your data is structured and how your master data is defined and how your metadata is clean and all well defined. So with that, once we set up your initial, maybe your groundwork to set up your initial data structures and I want to talk about a simple low-hanging fruit use case of utilizing a quick machine learning model to make your job better as a financial analyst or an FP&A team member. So one such use case is an automated cost classification using a machine learning model. So this is simply helping you automate the way you categorize your expenses among the and with those transactions, you clearly define your categories of expenses, like we spoke before, between IT, HR, reimbursement costs, your travel costs, and so on. And then you engineer your features around the expenses. So this could be your transaction amounts, your vendor timing patterns, your payment methods, and also any discount. And then you train your models using any simple. Let's talk about another use case for machine learning. So this would be the anomaly detection here. So these are simply identifying any outliers or anomalies in your expenses. So an example would be a spike in IT costs allocated to a product line unit. And this could be a true allocation or could be a misallocation. So this model identifies that. And for that to work, you need to clearly define your features for expenses. So that would involve transforming all your raw transaction data into analyzable features, like we spoke about, the categories, having your clear master and metadata defined. And then for your model itself, you build scoring around how much your expenses are deviating from expectations. And you can also set up some threshold alert routing with the expenses that cross those threshold and have them reviewed by the respect. And at the end of this process, you could also give feedback back to this model and help them identify or help them better identify anomalies in the future. So that means reducing your false positives and making your machine learning model work better with each cycle going forward. So typically, anomaly detection system employs multiple sophisticated approaches. They could be as simple as any unsupervised learning algorithms, or you could also utilize statistical techniques like z-score analysis, which are applicable for any distribution functions. And you can also go a step further and deploy advanced machine learning or deep learning autoencoders that really excel at recognizing complex patterns with extensive financial data sets. And as you can imagine, each model should be custom calibrated to your organization's size, complexity. So not one model doesn't fit for everybody, is what the point is. And with those models, you could also define dynamic thresholds. So the model incorporates any seasonal patterns and growth trends, while customizing sensitivity controls to allow precise tuning by expense category to minimize false positives. So these are some really high-level use cases which could be quickly achieved and established and make a big difference to your day-to-day expense management processes. Now let's talk about a bit more complex use case. So this is the time series forecasting of expenses. So where you would forecast your expenses. This is where your budgeting and long-term strategic forecasting comes into play. So as I mentioned, this is a bit more complex and needs careful selection of algorithms based on your time frames of. So starting with the smaller or shorter time frames for about 1 to 3 months, which is a quarter, you could use models such as the ARIMA model, which is the auto-regressive integrated moving average model, which is more suitable for stable expenses such as IT costs, which are more or less predictable. And for the not so stable expenses, like compliance costs, which are more variable depending on the activity of the business, expense forecasting, I recommend, which again would take into account and for this longer term, anything over 1 year or longer term strategic forecasting, you might have to use an ensemble of methods. And for each of these models focused on individual timeframes, you could use metrics such as the MAP for any accuracy measurement. And these are powerful metrics to help you identify if your model is working well and also to give it the right feedback and defining it further as you go into your process and use them for day-to-day use cases. So again, I want to highlight that for all these to work, you need to have your data defined in those hierarchies I've defined. You need to have your master data and metadata cleanly recognized and stored. So with that, I want to also recap on the implementation roadmap. So starting with the data readiness assessment. So this ties back to the step of organizing and figuring out your data sources. So your first step would be to conduct an assessment to identify you think about buying a machine learning model or a vendor. And once you have that step, the next step would be to assemble and create a team of data engineers and ML specialists and financial analysts. And this step is really the most important step. And that's where many organizations fumble, because it's very quick and easy to, but then having that team that uses that tool to its fullest extent and generates value for you, the model. And assuming you have your team set up, then the next step would be to a successful deployment. But needs to be in a phased approach. You don't want to build a complex machine learning model to begin with. You want to first have consensus and some champions across the board. So let's consider the whole process for the pilot deployment of the simple models with automated expense categorization and anomaly detection. And for those full time series expense forecasting, like we discussed in the previous slide, I would give it under 2 to 3 months, assuming that your initial models work well. And another step to keep in mind is to have a team or a process for continuous monitoring and improvement of the models, because even if the models are working very well, there's a need to refine and recalibrate and customize them with as your organization changes, grows, or especially if it is susceptible to any external factors, such as the macro data. I want to quickly touch upon the technology stack of options available for implementing these machine learning models in your organization. So if you are a small to medium sized business, there are many open source solutions available in the market for data processing, organize your data, to visualize it in a way that makes sense to all the business audience. And for deployment, tools like Flask and Docker are very effective for small to medium businesses. But if you're a more bigger business, there are many other enterprise solutions available. And nowadays, all the ERP and EPM tools out there come with inbuilt machine learning modules that you can quickly deploy and get value out of. It's a cost factor that you have to think about with those readily available models. Even those cloud service providers, and you think about your data integration architecture. So you build your data pipelines for ETL from data sources. You need to build a feature store for training your ML model, and then a model registry for deployment. And also think about any other API layers that you have to build to connect to front-end systems. So in case of finance services like investment bank, we build those API layers to your trading systems. Or if it's a manufacturing company, you build the API keys and your supply chain units and vendor tools to make sure that your expenses are captured effectively. And again, like I've stressed on before, having that monitoring and continuous. So with that, I want to close out this presentation. I want to present some real numbers from a real case study. So from a financial services process, it achieved remarkable improvements in classification accuracy. So it reduced its misclassification rate from 38% to 6%. And in that process, it achieved an annual savings of $2.4 million, just simply from better cost visibility and optimization that follows. And also, they were able to achieve 76% reduction in processing time, just utilizing a huge manpower for categorizing and reconciling your expenses. So the machine learning model was able to take care of all that and freeing up the time for the team to focus on more higher value. This was all achieved within like an 18-month time frame and showed an ROI of 3 to 5x. And the initial values with the low-hanging fruit models were achieved within 3 to 4 months. So I hope this inspires you and this was useful for you to understand and take